Okay, so I'm not sure who's online today. Hopefully there's someone other than myself. It looks like there's someone online. Took a little while to get online today. I was having problems getting a connection, so hopefully we won't get bounced out. Okay, so yesterday we did the law of sines and we solved first side. So if you weren't, hi Cynthia, if you weren't here yesterday, please go back and review the video because we talked about the law of sines. Just to recap, the law of sines is used when we don't have right angle triangles, when we only have a triangle with no right angle. So we have to use different formulas. We can't use the laws of our sine, cos, and tan ratios. We have to use the law of sines. The law of sines is very simple. Actually, it seems easier than the SOHCAHTOA, I think. So there's a relationship between the lengths of the sides and the size of the angles in triangles that are not right angles. So the length of a side divided by sine of the angle is equal to the length of another side divided by its angle, or the length of the third side divided by its angle. Again, we only use two ratios at once. So it's kind of like we show the three ratios equal to each other because there's three sides, but they're just saying this relationship just means that any side length divided by the sine of its angle is in the same proportion as the other two sides, okay? So what happens is this sets up a cross multiply and allows us to solve for a missing side. And what you have to do is you have to link the sides with the angles, right? Because that's the relationship that's formed. We set up a cross multiply, one ratio equal to the other. When we set up a cross multiply, we'll know three of the numbers, and there will only be a fourth number that's unknown, okay? Then we did a bunch of examples, and I asked you to do numbers, or just A to E on assignment 2, and I don't know if there were any questions. I think these were pretty straightforward. Cynthia, it seems like I know there might be someone else here too, but were there any questions at all on these? I could do one quick just to refresh. So if I choose C, for example, so how I do a law of sines question is I look for a ratio, I look for a partnership, a complete partnership. Here's a complete partnership. 48 degrees partners with 52. Okay, so that's my first ratio. 52 partners with sine of 48. Remember, an angle needs, right? An x is on the top. So therefore, I have a ratio, a cross multiply. We know how to solve for cross multiply. We cross multiply the numbers, right? These two numbers I know. So those are the numbers I multiply, and I divide out the guy without a partner, and that's going to give me the value of x. So x equals 52 times sine of 51 divided by sine of 48. In your calculator, and you really have to know how to use your calculator because every calculator is a little bit different. So I know that, Cynthia, you had what I call a backwards one, so you just have to learn how to use your calculator. If you learned how to use it in the grade 11 course, it works the same way as in the grade 12 course. So I have 52 times sine of 51. I don't know if you can see this in it's a little dark in here today. 52 times sine of 51 divided by sine of 48, hit the equal sign, and x equals 54.38, and that would be kilometers. Okay, so that's how we do a question like that. Very funny, Cynthia. Okay, we're going to go on today. Now, there's only 3 homework questions for the homework for this next part of law of sines. But I'm going to post another assignment on the blog too. I'll post an assignment with answers, and then you can get a little more practice that way. Okay, let's go back to page 13. So I'm back on page 13, and we're going to finish up the law of sines today. Okay. So once again, I'm using the law of sines, but this time I'm solving for angle measures. So that's the title of today's lesson, basically. The law of sines can be used to find the size of angles as well. Yesterday, we were just finding side lengths. And today, we're going to see that it can also be used for solving for angles. The nice thing is it's still the law of sines, right? It's still the law of sines. The law of sines doesn't change. And our approach doesn't really change either till the very last step. This one says determine the size of the angle labeled theta. Remember, we're labeling our unknown side lengths with x's, but unknown angles we label with thetas. And that's just custom, okay? So it's just customary to use, you might see in some textbooks or some teachers put an X here, but really, I think it's more proper to label side lengths with X's and unknown angles with thetas. That's just universally used to represent an unknown angle measure. So just like I did yesterday, I determine a partnership. And sure enough, there's a complete partnership, right? The law of sines will only work if you have a complete partnership. So 36 partners with sine of 60. Okay, that's my complete partnership. Now 27 partners with my unknown angle. Now remember, 27 is a length, it's inches, so my side lengths are going to go on top. And on the bottom, all I can write down is sine of theta, because this is what I don't know, okay? So you can see the setup's the same, except instead of an x unknown on top, we have a theta unknown on the bottom. Now, the same principles apply. What I do is I multiply the numbers that I know, okay? I multiply the numbers that I know, and I'm going to divide by my unknown. Okay. So this time I'm solving for sine of theta, right? So sine of theta equals, okay, I multiply these guys, 27 times sine 60 divided by my number without a complete partnership, okay? Now remember what I'm solving for in my calculator. I hope that you can see this. It's kind of dark, like I said, but there we go. 27 times sine 60 divided by 36. Now it's going to give us a funny number. It's going to give us a decimal number like this, but that's what you want initially. Now that's clearly not an angle measure. So sine theta equals 0.6495. I'm just going to put ... indicating I'm just leaving, this indicates I just leave this answer in my calculator, okay? So remember what you were told to solve for. You were told to solve for theta, right? Not sine of theta. Well, this is how I solve for theta. So if sine theta equals this decimal number, theta is going to equal, I have to cancel the sign out, and we have a button for that, right? So all I'm going to do is hit my sine theta, right? So right above the word sine, you can see the shift sign. Mine's in orange, can't really see it, but because it's in the second row, I have to hit my second function key at the top. Now yours might say shift. Mine says second. So all I do is hit my second sine button until I get this, and then I hit equals. And that gives me my theta. So theta equals 40 point, I guess I'm going to round to 2 decimals, 51 degrees. Okay? So let me know if you got that answer too. Now, Cynthia, I think you should be able to type in your 27 times 60 sine divided by 36. You'll still get a decimal answer. Okay. All right. Let's try the next one now. So see, everything is the same. I mean, obviously, instead of having an x, we have a sine theta. But everything's the same to that very last step. You just have to shift the sign out of there. Okay, let's see the next one. Determine the size of the angle labeled theta. Okay, so I see a nice partnership here. So that's my first ratio. 210 partners with sine of 31. that leaves me with, okay, 170 partnering with my unknown angle, sine of my unknown. Okay. So, oops, just trying to get this nice and straight. I multiply these guys, right? Divide by this one. And that's going to give me my initial decimal answer, my sine theta answer. Remember, sine theta is always just going to be a very small decimal number. And then I have to shift sign at the end to get my angle measure. So it's going to be 170 times sine 31 divided by 210. Okay, so sine theta equals, now remember, you're going to get a really small decimal answer, less than 1. 170 times sine 31 degrees divided by 210 equals, so there's my funny little decimal answer. I don't, 4169 ... Like, I'm only writing that in to remind you again that I am have to do that shift sign button, right? So theta equals shift sign, like cancel the sign out, equals 24.64 degrees. Okay. Okay, let's see. Last one. So it's kind of, this seems to be going quicker than for sure when we introduced law of sines. And I think that's because this is very, it's almost identical to yesterday's work, right? Because we're still using the law of sines. We're just solving for an angle. So there's just that one little step that's a little different at the end, that extra step. But really, everything else is the same, right? The setup's the same. So let's take a look at this last question. Determine theta. Okay, perfect. So we've got a partnership, perfect. 16 partners with sine of 127. And, okay, this is interesting. They're asking me to solve for theta, right? However, this is the side I'm given. And this side's partner is, these guys aren't partners, right? Theta's partner is this one. But the 9 inches that I'm given to work with, this is the angle I'm solving for, right? So the problem is I have to use this side, right? That's the only side they gave me, and I need an extra side. So the problem here is I'm going to be solving for the wrong angle, right? But if we remember our 180 rule, that won't cause a problem. So I have to use the information given. So these are the numbers I have to use. There's no doubt about it. This isn't like yesterday when I had an, if you're given 2 of the angles, I can easily find the third. So we're going to kind of use that in backwards. I have to use a different symbol for here. So instead of theta, I'm going to use the Greek. This is the first letter of the Greek alphabet. It looks like kind of a fish, but it's alpha. Okay. So that's what I'm going to use for my little, you can use any symbol. I suppose you could even have used an X if you wanted to, but I like keeping my X's for side lengths. Okay, so you can see that when in doubt, just kind of do something you know how to do, right? So I could solve for this mystery angle here. Sine of alpha equals 9 times sine 127 divided by 16. I'm still going to get some weird decimal answer, right? Always when I solve for sines, I'm going to get a very small decimal number. And sure enough, I get 0.4492 dot, dot, dot. Okay, I just want to solve for alpha. So I'm going to shift sign. And sure enough, here's my degree answer. Okay, so this is a preliminary answer, right? So alpha equals 26.69 degrees. Now, that's not what you were asked to do, right? You were actually asked to solve for theta. So of course, if you haven't forgotten the first lesson we learned, we've already used it numerous times. Theta then would equal, remember how to find the third angle? I take my 180, because 3 angles equal 180, and I take away my 127, and then, whoops, put an equal sign instead of a subtract sign. We just change that. And then I subtract 26.69 degrees, and whatever my leftover is, (26.31 degrees. Okay, so that's what theta equals. So that was a tricky one. It was very similar to yesterday when we had to solve. If you look at example 4 from yesterday, you can kind of see it on this sheet here. We had to use what we were given. We ended up solving for, or having to use our 180 rule in order to get the angle we needed to solve for x. Really handy. Don't forget that 180 degrees make up 3 angles of a triangle, and that can really come in handy when it doesn't look like you're given enough information to solve for either the side you're given or the angle that you need to find, okay, or the angle you're given. So that concludes the examples. Are there any questions at all? I don't know, I see only one person's live chatting. Remember, you can always contact me through the blog or through my regular email that's printed on your course outline. Now there are 3 extra questions. Maybe we'll go through these 3. I'll give you a minute. We'll go through these as a class, and then I'll post an extra assignment on the blog, and you can have extra practice. So maybe we'll just kind of use this as a practice day. Try this one now. I'm going to give you a minute or 2 to try this one, and then I'll post the answer as well. I'll do the answer with you. So I'm going to give you a minute to try that one. Okay, let's try this first one. So I see partnership. These two are partners, so it looks like I can set my okay, this is a very straightforward one. So sine theta is going to equal multiply, divide out, 23 times sine 70 divided by 35. Initially, I'm going to solve for that. I'm going to solve for 0.6175 dot. So theta is going to equal, okay, all I do, shift sign. Now in my calculator, I could just leave my decimal number in, and I think most of your calculators would work like that, and I do shift sign equals, and I get 38.13, okay? 0.13 degrees. Remember, we're solving for 2 decimal places, so I think the back. Okay, let's try this one then. I see partnership, perfect, and another perfect partnership. So I don't have to do anything with 180. If I don't have my partnerships clearly laid out at the beginning, I'm probably going to have to do something with the 180 rule, right? So 100 partners with sine of 50 degrees. 73 partners with sine of theta. So I multiply and divide, right? So sine theta equals 73 times sine 50 divided by 100. Anytime I'm solving for an angle, remember initially I get that funny decimal answer. Divided by 100. And I get 0.5592 ... That means I leave the decimal number in my calculator. So theta is shift sign. And I get 34.00 degrees. It worked out nice and round for me because I got a 1 after those double zeros. Okay, so I stay that way. Then very last question, let's see. Again, do I have a partnership? Yes, I do. These guys are partners, right? Complete partnership. These guys are not partners. If they're side by side, they're not partners. That means I'm going to solve for, I have to solve for kind of a secondary angle first. Then I'm going to have to use my 180 rule to find theta. All right, so let's see. My complete partnership partners with sine of 109. and 15 partners with sine of alpha. Okay, so I'm going to have to find sine of alpha first. Sine alpha equals 15 times sine 109 divided by 43. Okay, 15 times sine 109 divided by 43, and I get 0.3298 dot. So alpha equals 19.26 degrees. Okay, so you're almost there. Remember, you weren't actually asked to solve for sine of alpha, but that equals 19.26 degrees. That easily lets me, as theta will equal 180, take away the 109 that you know, right? Take away 19.26. And that's going to give me 51.74 degrees. Okay. So here's the answer to F, G, and H. So that doesn't leave you with any homework to do, but like I said earlier, I'm going to post another assignment as soon as I click off live stream. I'll post the video and I'll scan my notes in, and then I'll leave you with another assignment on the website for you to get a bit more practice with the law of sines. So remember, there are two ways to use the law of sines. You can either solve for a missing side or a missing angle measure. So I'll just stay on the line or on the live stream for another minute or so if you have any questions at all. And I don't know if Nicole is listening or she'll listen later, but I have been sending you emails back, Nicole. I don't know if they're going to your spam or junk mail, but maybe check that. I sent you another one this morning. So maybe check your junk folder, and they might have accidentally gone through there. I'm not sure how your email's set up, but I've been getting emails from you, Nicole. I guess you just haven't been getting mine. So hopefully we can clear that up. And I guess I don't see any questions right now. Remember, you can always get a hold of me through email as well. Remember, we only have tomorrow, and it's Good Friday this week. So Friday will be a holiday. So I will see you tomorrow, and be prepared to. No, Cynthia, we only have to get the alpha. We didn't have to get alpha first for these two, right? When you set your triangle up, if you've got clearly, if your partnerships are clearly represented, like this is a full partnership and this side goes with theta. If the side you're given partners with theta, you don't have to find alpha. Okay, here I have a complete partnership and the side I'm given partners with theta. So as long as the side you're given partners with theta, you don't have to find alpha. But you can see here, I had a complete partnership, and the side I was given did not partner with alpha. Or sorry, the side I was given did not partner with theta. The theta was just kind of by himself. That's the only time you have to find alpha. Does that make sense? So one more time, the side you're given, if it does not partner up with theta, that's when you have to use the 180 rule. Okay, perfect. All right. I don't see anyone else chiming in today, so I guess that's it. Of course, I can ask you or answer lots of questions tomorrow too, if you want to get a bit more practice on the assignment I post. So I will leave that for today, and I will you tomorrow. Okay, bye.